Okay, guys, what we're going to do today is we're going to do a polynomial inequality the long way. So no Desmos, no help other than arithmetic calculations with a calculator. So this is the throwback Thursday way of doing these things. Okay, so this is a polynomial inequality. It is a fourth degree polynomial, so I should expect 4 solutions. So I'm looking at it going, wow, I can't factor that at all. So what we're going to do is we're going to use something called the rational root theorem. Okay, and I'm not going to write out the text of the rational root theorem. You can totally Google that or look that up. But all it does is it gives you a list of possibilities. Okay, there is no guarantee that any of these roots will work. Okay, they're just possibles. And remember, a root is another word for a solution. So it's giving you a list of possible solutions. Again, no guarantee they're actually going to work, but they're giving you a jumping off point. So the first step of the rational root theorem is to take the constant term, which in this case is negative 20, and list off all the factors of it. Now, the fact that it's negative really doesn't matter. What really matters is that it's a 20. So 20 has a lot of factors. Let's make a list. You want to make sure you get them all. Okay, and then you're going to write down a list of factors of the lead coefficient, which in this case is 5. That's a much shorter list because 5 is prime. Okay, all right, so now what you do is you're going to build a list of possible rational roots. Now remember, the word rational means fraction, so we're going to build a list of fractions. The numbers from the 20 will be the numerator. The numbers from the 5 will be possible denominators. Okay, so my possible roots are, okay, usually what I do is I go from the denominator list and I list all of the numerators with that one denominator. So plus or minus 1 divided by 1, plus or minus 2 over 1, 4 over 1, 5 over 1, 10 over 1, 20 over 1. Okay, notice I'm using positive and negative. Okay, all right, then I make a second list with the second denominator. So this list is going to look like this. Okay, so now that looks like a really long list, and it is, but you do have some repeats. So if you have repeats, you can actually cut them out. So 5 over 5 is the same as 1, so I don't have to worry about that. 10 over 5 is the same as 2, and then 20 over 5 is the same as 4. So you do have some repeats. Okay, all right, now what you're going to do is you're going to look for solutions. Using the list of possibilities. And how you're going to do that is when you plug in one of these numbers, if it is a solution, it's going to give you 0. Okay, so if it results in a 0, then x equals that number that you plugged in is a solution. Okay, again, remember, we're not using calculators, we're not using Desmos, so this is going to take a bit, okay? All right, here we go. Now, usually what I do when I have to do it this way is I start off with the easiest possibility, which is 1, okay? So I'm going to go back to my original problem. Okay, and I'm going to plug in a 1. Okay, so remember, you're looking for zeros. Doing this makes you appreciate Desmos. Okay, so if I do that, I get 5 plus 22 minus 27 minus 64 minus 20. Negative 84. Not equal to 0, so x equals 1 does not work. Okay, now let's go for the next easiest, which is negative 1. Okay, we're just plugging in. All right, let's see here. Hey, look at that, look at that. I think I got a 0. Let's double check because I'm paranoid. Yep. So yay. Okay, so what that tells me is x equals negative 1 is a solution, or is a root. Okay, we would call that a critical point if we're solving the inequality. Now, what we're going to do is if x equals negative 1 is a root, then x plus 1 is a factor. Okay, so now if it's a factor, then it can divide our polynomial. And make it smaller. Okay. All right. So we're going to go back to our synthetic division. Now, if you watch the videos from yesterday, we did a couple synthetic division problems. So let's set this up for synthetic division. So what we're going to do is we are going to divide 5x to the fourth plus 22x to the third minus 27x squared minus 64x minus 20 divided by x plus 1. Okay, so now we're going to use synthetic. So using the synthetic, change the sign. That's the number that goes in your box from the x plus 1, but we put in a -1. Now we're going to make sure that we have all of the powers of x that we need. 4, 3, 2, 1, none. And write down the coefficients. Okay. All right. I'll bring the 5 down. Now we're going to multiply. Now we're just going to multiply, bring back up. Remember that pattern. You multiply and bring it back up. Oh, this should be a 40. Good thing we caught that. Oh, it messed us up. Phew. All right, there we go. That's -20. And then +20. Hey, look at that. We got a 0. So this is an extra indication that I'm doing things right. Okay. So now, instead of 5x to the fourth, when we divide, we make things smaller by a degree. So 5x to the third plus 17, x to the second minus 44x minus 20. Okay, so made it smaller. Well, that's nice, but I still can't factor it. So I'm going to have to go through the same process again. Okay, so since 1 didn't work the first time, it probably won't work again. Okay, but let's try a -1. Let's see if a -1 will work twice. Now, the nice thing about graphing is if you can find just 1 0, then you don't have to do this process over and over again. Okay. So again, you're going to plug in. You're going to look for your zeros. And hopefully you find one fairly quickly. And if I hear anybody thinking this sentence, Mrs. Harris, do I have to do it like this? No, you do not. You can totally use a graph if you want. Nope, that didn't give me a 0. Bummer, that gave me like a 36. So -1 does not work again. So now I'm going to go to the next number. Remember, 2 was on my list. So let's try 2. Okay, we're trying out 2. Let's see if it works. Hey, it worked. I got a 0. Okay, so since x equals 2 worked, okay, now I know that x minus 2 is a factor. So now I can use division to make it smaller. So again, we're going to use synthetic division. So I'm going to divide 5x cubed plus 17x squared minus 44x minus 20. And I'm going to divide that by x minus 2. Okay, again, we're going to use synthetic just because it's way faster than long division. If you want a lesson on that, I will be more than happy to make one. Okay, we're going to change the sign. The 2, positive 2 instead of negative 2 goes in the box. We're going to make sure we have all of our powers of x. Nobody skipped. Now, if you do have a skip, you're going to put in a 0. Okay. All right. Here we go. Bring the 5 down. Multiply it by a 2. Bring up the 10. 27. 2 times 27 is 54. That's 10. 2 times 10 is 20. We got a 0. So now I have 5x squared plus 27x plus 10. Okay, now I've taken a quartic to a cubic to a quadratic. Now, once you hit quadratic, you've got all of those little quadratic tricks that you can use, okay? So what you want to do is probably try to factor, which this thankfully does factor. So I have 5x like that. Okay, now remember, we want to set it to equal to 0. We're going to find our critical point so we can solve our inequality. So this is going to give me x equals negative 2/5, x equals negative 5. Okay. Whew. All right, so now what you have done is you have done this. You have taken 5x to the 4th plus 22x to the 3rd minus 27x squared minus 64x minus 20, and you have broken it down into its factors. Okay, and that gave you critical points of that. Okay, so remember at the very beginning, this wasn't an equation, this was an inequality. So we still need to find that inequality solution. Okay, and I believe it was greater than 0, correct? Way back in the beginning. Okay, so now what we're going to do is we're going to draw a number line. All right. So I have to put my critical points in the right order on my number line. So negative 5 is the most negative. Then negative 1. Then negative 2/5. Ooh, got a fraction. Yuck. All right. And then after 2/5, we have 2. like that. All right, so these will get closed dots. All right, so now we have 1, 2, 3, 4, 5 test intervals. So we get to do 5 test values. Okay. So I'm going to pick -10, -2. Okay, between 1 and 2/5. I am going to pick -4/5. Doesn't have to be exactly in between. Okay, and then for this one, I'm going to pick 0. And for this one, I am going to pick 3. Now, I'm going to run those numbers on my calculator. All I'm doing is I'm plugging those numbers into my equation to see if I get a true statement. Okay? So first I'm going to do 10, -10, excuse me. And I'm going to use all of the power of my calculator to help me out. So I'm going to use the power key. I'm not going to try to do any of this by myself. I am going to try, however, to type it in correctly. Okay, so when I plugged in the -10, I got, this is what I got. I got 25,920. Well, that is definitely greater than 0, so that's true. So I'm going to shade this portion of my graph. Okay. Now I'm going to plug in the -2. Okay, so 5, then -2 to the 4th. Now, if you can do some of this in your head, like -2 raised to the 3rd is 8, -8, then go ahead and do it. Okay, for that one, I got -96. That is not less than 0, so that is false. Okay, now I'm not going to shade there. So for ease of calculation, I'm going to change the -4/5 to a -0.8. Okay, so that'll make my life a little easier when typing it in on the calculator. Okay, so when I typed in that -4/5, I got 4.704. That is definitely greater than 0, so that's true. So I'm going to shade between. Okay, now if I plug in a 0, 0 is pretty easy to plug in because everything goes away except the -20. -20 is not less than 0, so that is a false statement, so I do not shade. Now I'm going to plug in a 3. And I get 544, which is true. So I'm going to shade this portion. Okay, so that means the answer to my inequality is -infinity to -5, close bracket, because it's greater than or equal to 0, union -1 to -2/5, close bracket, union, close bracket, 2 to infinity. Okay, now, so that's how you would do it almost completely by hand, no Desmos, no nothing. So basically, it's something that you should be aware of that you can do. You should know how to divide polynomials by synthetic. If you guys want to go through long, we can do that as well. This is all stuff you should know, okay? But also please know that there are alternate ways to do these type of problems, okay? So I will go ahead and post this, and if you have any questions, please feel free to ask me in office hours.